We use the same example to move the discussion towards the type 2 nested queries. With type 2 subqueries, the inner query references one or more tables in the outer query. Because of that, the inner query executes multiple times, once for each row of the outer query. In that sense, type 2 queries are like nested loops in programming. For each iteration slash row of the outer loop slash query, the entire inner loop slash query executes. Consider again employees who are not customers. Example at the top of MySQL 7 underscore 03 underscore subqueries 2. Let's see if I can find that one right here. Okay, the inner query selects rows from customer table, but only if the customer ID matches with the employee ID from the employee temp table. Notice that there is no inner join between the two. Employee table will appear in the from clause of the outer query. So, while in our example, the inner query generates only a single row for customer slash employee with ID 406, as we've used all along, in general, it would be a record set with multiple rows. Then the outer query will go employee by employee, and for each of the employee, it will determine whether or not it exists in the record set generated by the inner query. If it does not, it will be selected. If it does, like R406, it will not be selected. Okay, so we'll start by designing the inner query, selecting all columns for customer table where customer ID and employee ID match. Okay, I'm going to go do that here. A couple of blank rows, separating from the next example. We'll select all columns from customer table where customer ID is equal to employee underscore temp dot employee ID. Okay, so now I cannot, unlike the type 1 subqueries, I cannot test that because it's not independent of the other main query as it was the case for the type 1 nested queries in the previous video, right? So that makes it more complex. That makes the type 2 subqueries, nested queries examples slightly more complex. Okay, so what we're going to do is we're going to have to sort of give it a go all along, right? So we're going to plug this guy back to the top by putting it in parentheses. Trying to line this up never really works. And then using the so-called not exist clause as discussed earlier, right? So I'm going to save the changes. We're going to copy it, and we're going to go to Toad, start a new editor, paste it, and see if it runs. Right, all 97 from 1001 to 1097 as was discussed. Okay, I'm going to delete some of these blank rows. Okay, so with the next example, all right, starting right here, more complex. We're definitely moving to intermediate level SQL programming. The problem is to find all the customers with multiple orders who had all those orders taken by the same employee. So that's the problem statement, that single sentence. Here's the logic. Imagine the list of all the customers and their orders, okay, with customers having multiple orders, and then employees taking multiple orders, they're all repeating in this record set. Okay, so in this record set, they're all repeating. This is the basis for the outer or main query, part of which is sort of shown here. Okay. Then, for each row in this record set, we go through the record set composed of employees taking orders. The second record set, we have multiple employees as well as customer repeats again. So these two record sets are essentially the same, but are viewed differently. One has sort of customer emphasis type of perspective, but the other one is emphasizing employees. Okay, so now in the inner query, we match with the customer from the outer query, which creates a subset of the record set. This, and then we come to the second criteria, which is the key. If the employee that took an order from the same customer in outer query is not the same as the employee who took a different order for that same customer in the inner query, then we have violated our requirement. The customer with multiple order has all those taken by the same employee. So that's the key, and it's the most sort of complicated part of this problem and the implementation of the query. So this inner query will return a record set with one or more rows, and then where not exists, like the one we had over here, okay, will become false because records do exist. Okay, so the only way that the inner query will come up empty is if there is a customer with multiple orders that have the same employee in the outer and inner query taking those. Okay, so this is this link between the outer and inner query that's sort of tricky, right? So I'm going to go through this query almost from scratch here in Notepad++ and reinforce some of the points as I go along, right? As you can imagine, there should not be too many customers that satisfy this criteria, but to my surprise, there were 33 out of 322, or about 10%, as you'll see when I'm all done with it. Most of them had 2 or 3 orders, but quite a few had 4 and 5, with 2 customers having 6 and 8 orders taken by the same employee. And then we'll do a quick check using the already completed query right below here for a particular customer that had the most orders all taken by the same employee. Okay, so let's start by backing up here, right? We're going to select customer ID, first name, last name, and number of orders. This is the outer or main query. The customer column is referenced, customer table rather, is referenced with a letter C. Okay, so this is all part of the outer query, right? So customer C is then going to inner join orders, and this is going to be a table called O underscore out, emphasizing that this is the orders table belonging to the outer query. Okay, on C dot customer ID is O out dot customer ID, right? Again, so this is the from clause for the outer query. Okay, then we're going to have where not exists, and now we're going to do the inner query. We're going to have a couple of blank rows. We're going to I think I've had this parentheses. I think this opens. Yeah, these two matchups. I forgot to delete this one when I was prepping this. So now we're going to concentrate on this inner query, right? We're going to select everything from orders, but this orders table is the inner one, as designated by this alias O underscore IN or in. Inner joined with employee table that I call E underscore in, and I suppose I should have called this C out, or I just drop those two. It doesn't really matter. On the inner version of the orders table and its employee ID matches the inner employee table, or just the employee table and its employee ID. Okay, now where? Okay, so this is where the connection between the outer or main query and the inner or the subquery takes place. Okay, so the outer query and its customer ID, right? So you can sort of think of this as that index of the outer loop. Okay, matches, okay, the inner orders table and its customer ID. Okay, so that's kind of like the inner loop, the index of the inner loop. So this is the I, this is the J of sorts. Okay, so this is going to sort of then be viewing, for each customer from the outer query or main query, we're going to go run through all the customers in the inner query, and when they're the same, okay, that's going to create a subset or a record set. Now, the next piece is the key. And the employee from the outer query, an orders table, right, from the outer query, okay, is not equal to the employee from the inner query. Okay, so this line is the key line right here. Okay, if turns out to be true, that simply means that for the same customer, right? For the same customer, there is an order, okay, that has an employee ID that is different from another order, okay, by the same customer taken by a different employee ID. That is directly violating the requirement of the problem for that not to be the case. Okay, so if this is true, and assuming this is true, of course, for those matchups, then we're going to have some records in this subquery, right? This subquery is going to return some records. I'm trying to minimize number of almost empty lines, right? And then this is going to fail, right? Not exist. It's going to be false because some do exist. Okay, and those customers we do not want because they did not have all their orders taken by the same employee. Okay, obviously we group this by customer. We have to have more than one order because if the customer had only one order, then this problem sort of doesn't make sense because obviously then it will be taken by the same employee. And we're going to order them by number of orders descending, so to get those employees with the highest number of orders first. Okay, I'm going to save that. Again, I cannot test the inner query separately, okay, from the outer query because it uses, okay, literally the same orders table, right, repeated twice with different aliases, O out, O in. Okay, indicating that this is indeed a type 2 query, and therefore you can kind of tell now that this is a more complex example. I'm going to clean this out, start a new editor, paste it, and see any errors. No errors. Okay, and this returned the 33 out of 322 customers, okay, with multiple orders taken by the same employee. Somewhat surprising, I suppose, regardless of the fact that this is a made up example. Okay, about 10% of customers had multiple orders taken by the same employee over this time span. Okay, as you can see, this Bob Heinrich, right, customer ID 15, had 8 orders taken by the same employee, which we'll show in a second. Then there's a 6, there's several 5s, several 4s, and then the rest are 3s and 2s. Okay, so I'm going to switch back to the code and then double check this with Bob. Okay, double check this with Bob. Save, copy. And we should get those 8 orders, as this bottom right corner shows, taken by Bob. You can see they're all different orders by looking at the order ID, taken by the same employee named Ray Gonzalez. Okay, so we're going to clear this out. Make sure you save the code. It's saved. I'm going back to the presentation and pause.